Hi, today we'll be discussing about electricity chapter. So at first, switch it makes conducting link between the cell and the bulb. So this is what is the function of switch. Then electric circuit. A continuous and closed path of an electric circuit is called an electric current is called an electric circuit. So now circuit, if the circuit is broken anywhere, the current stops flowing and the bulb does not glow. So circuit uses metallic wires and electrons constitute the flow of charges. Electric current is expressed by the amount of charge flowing through a particular area in a unit time or rate of flow of electric charges. Now in earlier times, electric current was considered to be the flow of positive charges, and the direction of flow of positive charges were taken to be the direction of electric current. Conventionally, in an electric circuit, direction of electric current is taken as opposite to the direction of the flow of electrons, which are negative charges. Net charge, that is Q, flows across any cross section of a conductor in a time t, then the current I, so I is equal to this net charge upon time t, and the SI unit of electric charge is coulomb, that is represented in C. Electric current is expressed as in ampere, that is also written as A. So 1 ampere is constituted by the flow of 1 coulomb of charge per second, that is 1 A is equal to 1 C per 1 second. Small quantities of current are expressed in milliampere or microampere. Ammeter. It measures electric current in a circuit. It is always connected in a series in a circuit through which the current is to be measured. Electric current in circuit flows positive terminal of the cell to the negative terminal of the cell through bulb and ammeter. So this is how the electric current flows. Electric potential and potential difference. Flow of electric charge. For flow of charges in a conducting metallic wire, the gravity has no role to play. The electrons move only if there is a difference of electric pressure called the potential difference along the conductor. Now potential difference, this difference of potential may be produced by a battery consisting of one or more electric cell. Chemical actions within a cell generates the potential difference across the terminal of the cell even when no current is drawn from it. When the cell is connected to a conducting circuit element, the potential difference sets the charges in motion in the conductor and produces an electric current. So this is how electric current is produced. Potential difference between 2 points is work done upon charge. So V is equal to W upon Q. The SI unit of electric potential difference is volt. So 1 volt is the potential difference between 2 points in a current carrying conductors when 1 joule of work is done to move a charge of 1 coulomb from one point to the other. So 1 volt is equal to 1 joule upon 1 coulomb, where 1 volt is equal to 1 joule coulomb. This goes on top, so it becomes -1. Instrument to measure potential difference is voltmeter. It is always connected in parallel across the points between which the potential difference is to be measured. Now these are all the symbols how it is donated. So an electric cell is donated like this, a battery or a combination of cells, plug, key or switch when it is open, switch when it is closed, wire joint, wires crossing without joining, this is joining, this is without joining, then electric bulb, a resistance of a resistor of a resistance R, variable resistor or rheostat, this or this, ammeter and voltmeter. Moving to Ohm's law, the potential difference V across the end of a given metallic wire is an electric circuit is directly proportional to the current flowing through it, provided its temperature remains the same. This is called as Ohm's law. R is constant for the given metallic wire at a given temperature and is called its resistance. SI unit is ohm, that is written like this. So R is equal to V upon I. If the potential difference across the two ends of a conductor is 1 volt, then the current through it is 1 ampere. Then the resistance of R of the conductor is 1 ohm. So 1 ohm is equal to 1 volt upon 1 ampere. Variable resistance, a component used to regulate current without changing the voltage source. Rheostat is a device that is used to change the resistance in the circuit. Why current is different for different components? Now, certain components offer an easy path for the flow of electric current while others resist flow. Motion of electrons in an electric circuit constitute an electric current. The electrons are not completely free to move within a conductor. They are restrained by the attraction of the atoms among which they move. Thus, motion of electrons through conductor is retarded by its resistance. Now, good conductor, a component of a given size that offers a low resistance. Resistor, a conductor having some appreciable resistance. Poor conductors, a component of identical size that offers a higher resistance. So this offers lower resistance and this will offer higher resistance. Now, ammeter reading decreases to half when the length of wire is doubled. Same ammeter reading increases when a thicker wire of same material and of the same length is used in a circuit, and it changes a wire of different material of the same length and same area of cross section is used. The resistance of conductor depends on its length, area of cross section and nature of material. Now, this is the symbol for rho P. So constant proportionality, and is called the electrical resistivity of the material of the conductor. SI unit is resistivity, which is denoted like this. Metals and alloys that are low in resistivity is 10 raised to negative 8 and ohm meter to 10 raised to negative 6, and they are good conductors of electricity. Insulators like rubbers and glass are insulators. The resistivity of this is 10 raised to 12 to 10 raised to 17 ohm meter. Resistivity and resistance of material vary with the temperature. Why alloys are used in electrical heating devices like electric iron toasters? Because the resistivity of an alloy is generally higher than that of its constituent metals. Alloys do not oxidize, means they don't burn radially at high temperature. So that's the reason why they are used. Tungsten is used for filament of electric bulb. Copper and aluminium is used for electrical transmission lines. Now, resistance of system. Joining resistors, they can be joined in two ways, that is in series and parallel. So for series, electrical circuit in which three resistors having resistance R1, R2 and R3 are joined end to end. So they are joined like this, 1, 2 and 3. This is the main thing. So they are joined in line. Same way for parallel, combination of resistors in which three resistors are connected together between points X and Y. So here they are connected in a parallel. So R1, R2 and R3. For series, V is equal to V1 plus V2 plus V3. In series combination of resistors, the current is the same in every part of the circuit or the same current through each resistor. The reciprocal of the equivalent resistance of a group of resistors joined in parallel is equal to the sum of the reciprocal of the individual resistor. So reciprocal means 1 upon RB is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Now, disadvantages of series circuit is, major disadvantage of a series circuit is that when one component fails, the circuit is broken and none of the component works. Battery or a cell, source of electrical energy. chemical reactions within the cell generates the potential difference between its two terminals that sets the electrons in motion to flow the current through a resistor or system of resistors connected to the battery. Now, electric fan becomes warm if used continuously for a long time. This can come as give reason, that is, to maintain the current, the source has to keep expanding its energy. A part of source energy in maintaining the current may be consumed into useful work. The rest of the source energy may be expanded in heat to raise the temperature of gadgets. Heating effect of electric current. If the electric circuit is purely resistive, that is a configuration of resistor only connected to a battery, the source energy continuously get dispatched entirely in form of heat. This is used in electric heater, electric iron. Joule's law of heating. Heat produced in a resistor is directly proportional to the square of current for a given resistance. It is directly proportional to resistance for a given current, directly proportional to the time for which the current flows through the resistor. Devices based on Joule heating are laundry iron, electric toaster, electric oven, electric kettle, electric heater. How electric heating produces light. Now this works in case of electric bulb. So the filament must retain as much of heat generated as possible that it gets very hot and emits light. It must not melt at such high temperature. A strong metal with high melting point like tungsten is used for making bulb filaments. The filament should be thermally isolated using insulating supports, etc. The bulbs are usually filled with chemically inactive nitrogen and argon gases to prolong the life of filament. Most of the power consumed by the filament appears as heat, but smaller part of it is in form of light radiated. Now, fuse protects circuit and appliances by stopping the flow of an unduly high electric current. So this is the use of fuse. It is placed in series with device. It consists of a piece of wire made of metal or an alloy of appropriate melting point, example aluminium, copper, iron, lead. If larger current than the specified value flows through the circuit, the temperature of fuse wire increases. This melts the fuse wire and breaks the circuit. So this is how the circuit is broken. Fuse used for domestic purpose rates like 1 ampere, 2 ampere, 3 like that. Then electric power, the rate of doing work is power. This is also rate of consumption of energy. P is equal to VI. SI unit is watt. Now what is watt? Power consumed by a device that carries 1 ampere of current when operated at a potential difference of 1 volt. Watt is smaller, so it is a smaller value, so we use kilowatt. So 1 kilowatt is like 1000 watts. 1 watt per hour. Energy consumed when 1 watt of power is used for 1 hour. Commercial unit electrical energy, that is kilowatt per hour. This is used in commercial.